Okay, so let's go over a couple of these antiderivatives. Notice I'm not going from f to f prime and then going backwards. I'm just doing the antiderivative. You can see the notation that indicates the antiderivative, meaning I want to get back to my original function. All right, so the antiderivative of this, as we mentioned, pull out the number 2 over 9. There it is. Okay, so then we're going to do x raised to the 4 plus 1. There's step 1, add 1 to the power, and then step 2 is to divide by the new power. So divide by 4 plus 1 plus c. So this should equal 2 over 9 x to the 5th power over 5 plus c. Okay, so notice there's a 1 right here. So I can multiply straight across and I get 2x to the 5th power all over 45 plus c. Okay, you'll notice that there's this constant thread of ideas, which is why I'm connecting them with the equal sign. Okay, I will again explain what the c is, I just won't do it right now. All right, flip that over. Here's another example. Notice I'm going to do a rewrite. And I'll put the 6 over 7 here because I know I'm going to pull it out. And then I'm going to bring up that x squared by negating the power. All right, so now I'm ready to take the antiderivative. So this equals, notice my 6/7 is already pulled out, x to the -2 plus 1 divided by this new power, -2 plus 1. Okay, so step 1 is to add 1 to whatever your old power was, and then step 2 is to divide by your new power, plus c. All right, so this equals 6 over 7, x to the -1 over -1 plus c. Okay, I'll combine these two. There's a 1 here, in case you're confused. So this equals -6 over 7. I don't want to write this as x to the -1. I mean, I'll do it one more time just so that you can see what's occurring. So this is 6 over 7, the x goes to the basement, plus c. Right? Why? Because this is a negative power. Okay, you could rewrite that as 6 over 7x to the first, plus c if you so desire. All right, so there's those. Let's try another. All right, so I'm going to pull out this 4, and I will rewrite this chunk right here as x to the 5 over 2. If you remember, the square root is an invisible 2 there, and the 2 is going to travel around and sit right underneath the 5. That's why I'm writing it like that. This is not a derivative, this is a rewrite. Oops. Right? I'm just writing it in a different form so that I can take its antiderivative. Okay, it's not a derivative, not an antiderivative. Right? It's just a rewrite. So this equals, okay, again, I'm continuing this idea. 4x to the 5/2 plus 1. So add 1 to the power. And then the second part is to divide by a new power, 5/2 plus 1. Okay? So this equals, now some of you may struggle to figure out what 5/2 plus 1 is. As I mentioned earlier, you could just do it in your calculator. So parentheses, 5 divided by 2, close the parentheses off, plus 1. Press enter, and you're going to go to, if you remember, you go to math, M-A-T-H, right here, and just go to where it says FRAC, number 1, and it'll convert it for you, 7/2. So this is 4x to the 7/2 divided by 7/2. Okay, by the way, I knew that this was 4 over 1, right? That's why that 4 is going in the numerator. Let me correct this. This should have a plus c here. This is an error on my part, plus c. I Back in high school, your teacher told you when you divide by a fraction, it's the same as multiplying by the reciprocal. So I'm going to rewrite this as 4 over 1 because it's kind of convenient for me to do so. Again, dividing by a fraction is the same as multiplying by a reciprocal. 4 over 1 divided by 7 over 2 equals 4 over 1 times 2 over 7. There's the reciprocal of that, right? Reciprocal, right? Times the square root, let's change this, of x to the 7th plus c. Almost there. So multiplying straight across, I get 8 over multiplying straight across, 7. And in the numerator, I get the square root of x to the 7th plus c. So this is one way you can write it. Again, since the x is to a positive power, you can more distinctively write that in the numerator if you so desire, right? Because that is definitely where it resides. Okay, so here's the fourth one. Let's rewrite this. Notice the 8 is in the numerator. It doesn't look like there's anything in the denominator, but there is. There's a 1. So I'm going to pull out 8 over 1, like that. The integral of 1 over the 4th root of x cubed dx as a rewrite. Okay, so now we can see that this is distinctively in the denominator, right? Hopefully you could have seen it there. So this equals 8 over 1, the integral of 1 over, oops, kind of got ahead of myself. So this equals 8 over 1, the integral of 1 over x to the 3 over 4 dx, right? Which equals 8 over 1, the integral of x to the negative 3 over 4 dx. Okay, all of this is just a rewrite. Notice I haven't even gotten to the antiderivative. I just kind of took my time in doing the rewrites. Okay, so here all I've done is just take the 8 out. This is all I dealt with. At this particular point, after I made that mistake, all I'm dealing with is just this power right here, right? And then in this step, all I've done is I've just brought up the x by negating the power. Now I'm ready for the antiderivative. So notice this is a constant thought. This is 8x to the negative 3/4 plus 1 divided by negative 3/4 plus 1, which plus c, which equals 8x to the positive 1/4. You can do that in your calculator. All over positive 1/4 plus c. Almost there. Okay, so again, when you divide by a fraction, it's the same as multiplying by the reciprocal. So this equals 8 over 1 times 4 over 1. You're flipping this over. And then we have the 4th root of x to the 1st plus c. Alright, so this would equal 32. 4th root of x to the 1st plus c. Okay, and I'm continuing that thought. Alright, so that's good. We've got 4 of them done. Let's try a couple more. Then we'll call it quits. This one, what happens if you just have a number and a variable? So let's rewrite this. This is the antiderivative of 17x to the 1st power dx. There's only one x sitting there. Okay, so now I'm ready to do what I've been doing for all of the other problems. Pull the 17 out. Then we have x to the 1 plus 1, all over 1 plus 1, plus c. So this equals 17x squared over 2, or 17 halves. Notice you can make the 17 over 1 if you so desire. 17 halves times x squared plus c. Okay? So what happens, okay, let me be clear on this one. You can actually see the x here, right? There is an x. So it's a little bit easier to tackle than a problem like this where you cannot see an x. All right, so what you have to remember is you can do some rewrites. So this is the integral of 91 times 1 dx. 91 times 1 is still 91. So we're going to rewrite this as the integral of 91. Turns out that a fancy way of writing 1 is x to the 0th power dx. Okay, so to be clear, all of this is just rewrites. Okay, I haven't actually taken the antiderivative. 91 is the same as 91 times 1, which is the same as 91 times x to the 0. Okay, so now I'm ready to do my antiderivative because I have x to some power. So my antiderivative, if I do this process of adding 1 to the power divided by the new power, I get 91 x to the 0 plus 1 all over 0 plus 1. Same two steps, right? Plus c. So this equals 91 x to the first all over 1 plus c. All right, so there's one more that I want us to talk about. And then I'll be done. So the question is, what would happen if you have the antiderivative of 1 over x dx? All right, I'll get to that in my next video.